talk. So thanks so much everyone for coming here. My name is Jossi Wolf, and today I'll be talking about our experiences from migrating LiveData to Coroutines and Flow. So I work at Snap Mobile, and we're this kind of agency slash consultancy thing. So we go into projects and we help folks improve their apps, and we help folks build new apps. Before we dive into the talk totally, it's 2020, and 2020 is just something else. So I want to start this up with the dog picture. So we see a lot of projects in my company, and recently we joined a new project, and it had LiveData like everywhere, literally everywhere, in every layer there was LiveData. So it followed a kind of standard-ish architecture separation between UI layer, view model, and the repository. And what was not so common, or what we hadn't encountered before about this, was that all the layers were communicating through LiveData for every async operation, but also for some operations that were running synchronously. So it was all a bit weird, and we just hadn't seen it before. We were like, okay, this looks fine. And so what even is LiveData? LiveData is an observable data holder class. So basically, LiveData is just an implementation of the observer pattern. Let's look at how that actually looks in code. What you can say, for example, in your view model is, all right, we have this member field, and that's called latest data. It's a LiveData that contains strings, and we assign it a new mutable LiveData instance. So mutable LiveData means that we can actually mutate the value of that LiveData. If you just had a LiveData like that, it's not mutable, so you couldn't change the value, which makes sense if you have the value up front, but if you're waiting for some data to be loaded, that doesn't make sense. So what you can then do is you can fetch some data or do whatever asynchronously, and then you can post that value to the LiveData. And in your UI layer, you can observe this LiveData. So you can call observe with the view lifecycle owner, and then you pass it an observer. In our case, we just pass a lambda, which is empty. So this is super, super awesome, because LiveData takes care of a lot of things for us here. Since we pass it the view lifecycle owner, it takes care of the lifecycle subscription, and making sure that everything is unsubscribed when it needs to be unsubscribed, when the fragment is paused, and then it becomes active again when the fragment becomes active again. So there's a lot of stuff which it gives you for free, which is super, super nice. Also, one behavior of LiveData is that when you subscribe, you always get the latest value that was emitted, or the last value that was emitted. So if you had a fragment and it was destroyed, but your view model survived and your fragment become active again, and you would call observe on that LiveData, you would get the latest value. And that means your UI is already there. So it's a really great way for keeping state of some things. So LiveData is really great. I want to make sure that I'm not like sounding like, oh, LiveData is horrible and the world is going under. Well, it's 2020, so it kind of is. But so LiveData is great when it's used properly. So when we joined this code base, we were like, okay, this is a bit unconventional. We hadn't seen it before. Then again, it had been recommended by some Google samples. But after like a couple of days, we were like, wait, what is going on? There are UI thread blocks all over the place. So we took a bit of time to investigate, and it turned out that LiveData and its execution context have some caveats, fun caveats. So I want to show you what some of our code look like? Well, it's not like actual code excerpts, but it's really similar. So we would have a repository, and in there we would have a method, for example, called fetch opening hours, returns the live data with opening hours information. In our view model, we would then have another function, right, which would just basically take that function, call that function from the repository, and then run some data transformations using map. Looks fine, right? That's what we were thinking. But then we went to investigate and looked into our code really hard, step by step. And it turned out that actually, so we were making sure that this fetch supermarket opening hours in the view model was being called on a background thread because we didn't want to block the main thread, obviously. And then we were like, okay, this should be called on a background thread as well, right? Why would it change? Turns out this is what's going on. So everything inside the Lambda from the map call was being called on the main thread. Not great if you have like huge data sets, or if you're running some more complex transformations. In our case, for some transformations, we were doing database calls, which we probably should not have in the first place, but that's what we were living with, right? So to understand why that's happening, let's take a look at the source code for the transformations code. So this is what the map function looks like. So it takes the source, or it's an extension function, and in that case, you wouldn't have the source parameter. And then it has the map function, which is just a lambda, right, that we pass. And so what it does first is it creates a mediator live data of the result type that we want. And then it calls add source on this mediator live data. So that means that whenever this source that we pass in emits a value, the following lambda will be called. And in that, we get a new value, which is x, right? And then we call result.setValue. So we set the value of this mediator live data whenever the source emits a new value. And we set the value with the result of that map function. So we invoke the map function with a new value, and then that map function returns a value, and that's what we set the mediator live data to. So finally, we return the result, which is our live data. And that's still like, that looks fine, right? Let's keep in mind that add source, this lambda, that's an observer as well. So here's something fun we learned about observers and events in live data. So events are dispatched on the main thread, always. Turns out it actually makes sense to read the documentation. Yes. But so that means that live data observers are always being called on the main thread. And that means that for every data transformation, those lambdas will be called on a main thread, which is not great, because that's not entirely obvious if you are not reading the documentation very, very closely. So it's super, super easy to let things slide when using live data, even though it's super awesome and it gives you lots of stuff for free. So we were in a kind of bad situation because we had this pretty big code base, which we didn't really know. And we had this new project and time pressure to deliver. So we were like, okay, I guess we have two options. Number one is replacing live data. Just replace it by something else. Not sure why, not sure what, but we'll see. Or we could make sure threading is done properly. So we were like, okay, what's kind of being in an active project, what's the least harmful thing we can do? And we were like, okay, making sure threading is done properly kind of sounds like the less invasive thing. So we tried a bit. We looked, can we make sure this is done properly? And it turned out we couldn't. The code was very entangled, and we couldn't make sure that for each and every single transformations call and other things we were doing with LiveData, we couldn't make sure that threading is done properly because it was just too much stuff, not enough abstraction behind it. And also we didn't own the transformations code because it was coming from the LiveData artifact. So fun thing, we went for replacing LiveData because why not? Okay. So we were looking a bit for options that we could go for. There's a couple, but first we decided to take another look at what we were dealing with and kind of categorize that. So we managed to divide up our use cases for anything asynchronous that we were using LiveData for before into one-shot events and streams of data, like actual streams of data. So a one-shot event or function is just something that only returns one value. So LiveData that would only return one value, we're like, that doesn't really need to be a LiveData. So we went for coroutines. We had worked with coroutines before, and it is the recommended solution by Google for asynchronity. And it works very, very well for just, having functions that do things and return values, which was exactly what a lot of use cases were. That usually makes sense to migrate to. And then for streams of data, we were like, okay, can we keep LiveData? No, probably not. What else could we go for? Since we're going for coroutines already, we decided to go for Flow. Similarly, we had used Flow before, and we made great experiences with it. There's still, similar complexity to other frameworks like RX Java, but it's a lot, it's a lot less, and it's a lot easier and more lightweight and Kotlin first. And we had great success with it previously, and we did in this project as well, and it worked out very, very well. So we were dealing with this big code base, and we were like, okay, how do we even convert or migrate? Like, how does that work? So let's take a look at one of our repositories. I previously showed you there is like a function in it that returned LiveData, but let's take a look at the actual code. I know this is a lot of code, and I don't want you to have to understand it all. But the point is, we were still using callbacks with retrofit. Now, this isn't directly related to LiveData, but it's worth a mention since we were migrating to coroutines anyways, and retrofit has coroutines support. We decided to just migrate all our coroutines interfaces to all our retrofit interfaces to coroutines. And with that, there was already like a big part of this code was already gone after that, which was great. So we could focus on more important things. So if you look at the code that is going on in here, you can see that like the actual thing that is happening, there is no real logic anyways. It's just delegating to the retrofit interface, the POI service. The actual thing that's happening in here is just this. It's just the one line. And that works very, very well as a coroutine, just by saying, okay, this is the code we want to run. Or if we had, custom logic in there, that would have worked as well, right? The point is, for just for creating the live data, like, creating the new mutable live data instance and then posting the value and returning that live data. That's a lot of code that we don't actually care about, right? Because that's very boilerplate. Yeah. So we first extracted all the important things, all the actual logic into our methods, into our coroutine methods, into our suspend functions. And then we decided to introduce migration helpers. So these were functions which were being named fetch opening hours as live data or something, right? So they would have the suffix as live data, and they would return live data. And what's super awesome is there's this live data lambda builder. It's super similar to building a flow if you've done that before. So you can just call emit, and then it emits a value, and you don't have all the annoying stuff of manually creating a new mutable live data instance again and again and again, and assigning the value and so on. So then we annotated this migration helper as a deprecated. We said, all right, this is, want to make sure everyone who uses this code base understands you should not use this anymore, and we can probably migrate this. Looks great. Kind of, yes, already, almost. So we were talking about threading, right? And this lambda, what about the execution context? So we're still being called on the main thread. That's because the default dispatcher this uses is the main dispatcher. And you can, in this lambda, you can also call, suspend functions, which is super nice. And you can similarly, with that, you can specify a context. So you can say, all right, let's run this lambda on dispatchers.io. So we want to run it on the background thread. And with that, we sorted, those issues of blocking our main thread everywhere. Almost. We still had the view models to migrate. So when we were calling fetch opening hours before, we now renamed this to fetch opening hours as live data. And we would get this nice hint in the IDE saying, hey, this is deprecated. Don't use it anymore. This is what the deprecated function does for us. So there's like a nice visual hint telling you about this. But we were still having the issue of our transformations, right? So going back to the repository with the migration helper, we just decided, okay, we probably should not have live data and lifecycle related things in our repository anyways. So let's just copy over the code from this migration helper. So now we would just have the live data lambda builder in the view model, and then fetch the opening hours from the repository. That's our refactored suspend function, and then run some data transformations, right? We want to filter some null values because we don't care about them, and then emit that. And with that, everything is being called on the right thread that we want, which is super nice. And we have a lot more control over the execution context, and it's a lot less ambiguous than what it was before. So that's our strategy for converting to coroutines. So extracting all important logic from our methods into just, as pure as possible functions. That's probably a very hard part if you are in an entangled code base. Second, creating those migration helpers. And then third, just, pulling all the stuff that you need to the view model if possible. But then we had, we had our actual streams of data where we were using LiveData for not only like one-shot values, but also for, just emitting things maybe from the cache and so on. So let's talk about converting to Flow. First up, this is what our code looked like roughly, right? For, this is an example for retrieving data from the cache. So what would be going on was we would look up the cached value, see if it's null, and if it's not null, we would post that to the LiveData, and then we would fetch new data and also post that to the LiveData. So you can see again that, in here, there is only like 3 actual lines of, or 2.5 lines of actual code that we care about. And the other 3.5 are just LiveData related. So first step, changing the return type to Flow. And then similar to the LiveData builder, there's also the Flow builder. So that works just almost the same way. And in there, you can call suspend functions, and then you can emit values. So it has a very similar API to the LiveData Lambda builder as well. So the nice thing is that this is what we would have in our repositories, right, as a refactored code, and we wanted to create migration helpers again. So what we did was we just said, all right, as LiveData. So there's this genius extension function, which is on flows, which is called as LiveData, and it just converts a flow to a LiveData, which is super, super nice for migrating or for communicating between layers that use Flow and LiveData. Similarly to, as we specified the context before with the LiveData Lambda builder, we didn't do this for the Flow builder because it doesn't support that. Execution context in Flow works a little bit differently. I'm going to link a blog post later. So you can say, you can pass the execution context for this Flow Lambda builder to the as LiveData call. And so we just say again, all right, let's run this on the background thread. And that gives us nice control that we need, that we wanted. And we would also just annotate those, those migration helpers as deprecated to say, all right, please don't use this anymore. So from there, migrating the view models was, a lot easier because we just needed to rename everything to the to the new migration helper names. So when we had fetch supermarket details before, it would now just be fetch supermarket details as LiveData. And then slowly, step by step, we started pulling this out of the repositories into the view models and just eliminating code where we possibly could. And that worked very, very well. And after, I guess, a couple of weeks, we have nicely cleaned up our code base, and would definitely recommend doing this kind of migration. So there is another topic which I wanted to touch on, which is still super experimental and super new. And there is not a lot of info about this out yet, but people keep talking about this. So I thought I should give this a quick mention. So let's talk a bit about StateFlow. So StateFlow is a flow that represents a read-only state with a single updatable data value that emits updates to the value to its collectors. Honestly, I just think this is not a great, concise summary. I still wanted to take this because this is the first sentence from the StateFlow documentation. But so basically, a StateFlow is a flow that is specifically meant for representing state. It has one value, and then it emits that to the collectors, and it always emits the latest value that was there when you subscribe. So basically, it is like LiveData without the lifecycle awareness, like directly built into the StateFlow type. So you're not tied to the lifecycle, which is very nice. So I want to show you what migrating would look like. So when you were having in a view model, when we were having LiveData before, now the first step would probably be to make that return unit, make that return nothing. Then you would run your code and Then you would launch a new coroutine in the view model scope. In this case, we also want to make sure this is running on background thread, right? I know, super important. And then we call our repository with the fetch opening hours method. And then we set the value of the underscore opening hours state property. So the underscore opening hours state and the opening hours state properties look like this, or memories look like this. So underscore opening hours state, I also made this mistake again. Underscore opening hours state should be private because it's a mutable state flow. So there's state flow, which is immutable, and then there's mutable state flow, which value can change. So you don't want to emit the mutable flow to, you don't want to expose the mutable flow to outside subscriptors. That would be pretty bad, or just pretty chaotic. You don't want to do that. And so we have that as private. Just imagine it's it as private. So we create a new StateFlow instance for that, and the initial value of that is opening our state.empty to indicate, right, we don't have any value yet. Or if you're using some result type, that could also indicate that things are in flight or empty or something. And then we are exposing the opening hour state, which is just the StateFlow. So mutable StateFlow inherits from StateFlow, so we can just expose this underscore opening hour state as the opening hour state, but not mutable. I hope that makes sense. And then what you can do, so we just set the value of that underscore opening hour state, and basically the API is super similar to LiveData as well. And then in the UI layer, we would take this StateFlow, and we would say on each value that is emitted, call render opening hours, and we would make sure to launch that in the lifecycle scope. So that makes sure that everything is, so the lifecycle scope, right? A job could get canceled when the lifecycle, when the UI component has reached a state in the lifecycle which is not active anymore, or when it becomes active again. So this is super nice, and this is basically similar to calling observe with a view lifecycle owner on the LiveData. So you can actually say this. You can call this on every flow. You can say launch in with the given scope, and that launches it right within the given scope. Similarly, you could also call lifecycle scope dot launch and then call view model dot opening hours state dot collect. That works as well, whatever you prefer. So this is just a nice kind of syntax on top of that. So why would you actually use StateFlow, right? There's a couple of things. First of all, you're going from 2 APIs to having 1 API. So you don't have to care about LiveData and Flow side by side anymore, but you only have to care about Flow, which is super, super nice, right? 1 dependency less, that's super great. 1 thing less to learn, that's awesome. And probably less code. Execution context. So all methods of the StateFlow are thread safe and can be safely invoked from concurrent coroutines without external synchronization. Super, super nice. So basically it takes care of so much things that LiveData just was not designed for, and that people still use it for. So that's super, super great. So you get a lot more control over the execution context, and the design for this is just a lot better. And then finally, it does integrate very nicely with Jetpack Compose. If you have a flow, you can just call collect the state, or if you just use that value from the StateFlow, that'll trigger a recomposition. So this is used in a couple of official samples, or maybe in all of them. So make sure to look out for that. So it's a very, very nice thing to have, and it's probably very future-proof, future-safe. But there are a couple of drawbacks. I just want to say this is still experimental. So StateFlow has been merged into the Coroutines library, and you can play with it with the latest Coroutines version. Things are still a bit unclear though. There's still operators which are missing, and some of the design things are just still ongoing and not super decided yet. So you probably should not go employ this in production, but keep an eye out for it. If you're looking to migrate away from LiveData, I guess in a couple of weeks or in a couple of months, there could be something, so make sure to keep an eye out for that. I do have a couple of resources, which I will also post on my Twitter. Make sure to look there in a couple of minutes. I'll also post the link to the slides there. So the resources are obviously the documentation on LiveData. If you find yourself in a code base with lots of LiveData, it does make sense to fully read this. Surprise. And then I did write a blog post about why you shouldn't use LiveData in repositories. And there's a post about execution context in Kotlin flows from Roman Elizarov. I hope I pronounced the name right. Sorry if not. And that gives some great insight about how controlling execution context is designed for Kotlin flows, why it's designed that way. And finally, there's the official documentation for StateFlow. So make sure to take a look at that as well. So thanks all so much for bearing with me for so long. Thanks so much for listening and attending. I hope that this actually was streaming the whole time and things weren't going wrong. Here's another dog picture.